All right, so we're going to talk about my favorite thing in the whole world, which is conversion factors. I love conversion factors because they give me the ability to solve problems that look really complicated. If I can find some conversion factors that I can use, I can turn any unit into any unit. I can solve any problem if I can find a conversion factor. And the math to solve it is the same for every conversion. So it's universal. And then sometimes you have to use a little bit of algebra to maybe solve something, but if you're just converting units and you can find equalities, then you can use this one method to kind of do a long line of work that you know your answer is right because you can check it. And so I love conversion factors. And so we're going to look at your SI prefixes and turn them into conversions. I'm going to show you how I do that. Turn SI prefixes into conversions. So first, we're going to write the definition. So this is how I teach this, assuming that you don't already have them memorized. I think this is the easiest way for students to learn it. So let's just use kilo, for example. So I know kilo, and leave some space around it, is equal to what? 10 to the 3 is the definition, or 1,000, sure. So first we're going to write a definition. Then we're going to input whatever base unit you want to use. That's going to be grams, liters, meters, etc. Doesn't matter. It could be a made-up unit if you want to use a made-up unit. A kilo dog, right, is 1,000 dogs. So we have our K and our 10 to the 3, and that's what it equals. So I'm not really making anything up here. And then let's add in grams. Kilograms is kilograms. Notice that I just read that a certain way. Kilo equals kilo because 10 to the 3 is equal to kilo. This is kilograms, and this side is also kilograms. That's why they're equal. And then your last step is to put a 1 in front of your prefix. So we have our kilogram equals our kilogram, and we're going to stick a 1 here so we don't get confused with what numbers go where. Now we have an equality. So this equality is really what you want to get, because if you can make an equality, we can turn it into a conversion factor. So let me show you how to do that. To turn equality into conversion factor that we can use in math. All right, so let's just do a quick little background. So can everyone agree that this is true? 3 equals 3? Cool, great. We're all on the same page. What happens if I put 3 over 3? What does that equal? That equals 1, right? Okay. So what you're just telling me here, or hopefully that you're telling me that you agree with this, that if I put 2 things that are equal to each other on top of each other in a fraction, their value is essentially 1, right? Okay. Hold on to that idea because that's what we're going to be doing here. So if I want to turn this equality into a conversion factor, 2 things that are equal to each other can go on top of each other and essentially equal 1. So I can write, oops, do not want this color. Write equality as a fraction. And either way works. So I can say a kilogram over 10 to the 3 grams, or I can say 10 to the 3 grams over a kilogram. And guess what? They both equal 1. So let's look at it in an example to really show you like the power of this. So let's say I want to change some grams to kilograms. So if I have 1,200 grams and I want to know how many kilograms that is. Am I actually changing the mass that I measured, that 1,200 grams? Am I changing the mass there if I convert it to kilograms? The answer is no. not changing the mass. I'm just changing how I tell you about it. Right? I don't want to tell you in grams. I want to tell you in kilograms, but I'm not actually changing my measurement. So what I'm going to do is I need to not change my number. I need to multiply by 1, right? So I'm going to do that. I'm going to take my 1,200 grams and I'm going to times it by a fraction to get rid of the grams and give me kilograms. So I'm going to use this version because if I put 2 units on top and bottom of each other, they're going to cancel out. I'm left with kilograms. And so I will have 1,200 divided by 10 to the 3, which is going to be 1.2 kilograms. So to put it in the calculator if you want to, or you can move that decimal 3 times to the left. Or you can take 1,200 times 10 to the negative 3 if you are really good at exponent math. And then turn it back into normal conversion. So that's essentially how we're using it. So what are we doing? We're not changing the measurement. We're just changing how we tell you, how we represent it. Because essentially, this whole conversion is equal to 1. And that's really cool to me, that we can just say like, okay, these 2 things are equal to each other. So if I put them on top of each other, I'm not actually changing the value of what I measured. I'm just changing how I represent that value. So anytime you go from pounds to, like, are you changing your patient's mass when you weigh them if you tell them in kilograms or pounds? No, it's the same. It's just, I mean, yes, they're different numbers now, but their actual mass of person that you're measuring is the same in both cases. And so this is the beauty of using conversion factors. Okay, so let's try some. If I tell you a pint of blood contains 473 milliliters of blood, which of the following conversions could I use? Did you do it? Did you guess? If you haven't, pause it and guess. So we have a couple things we have to do. We have to make sure 1 pint stays together and 473 milliliters stay together. So if you chose A, that's wrong. What did I do with A? I switched my numbers up, and that's not true. The 2 things on top of each other have to be equal to each other. So what does my equality look like? My equality is 1 pint equals 473 milliliters, right? So I can put 1 pint on the top, or I can put 1 pint on the bottom, but I have to make sure the 1 and the pint stay together. Because if I don't do that, so 473 pints does definitely not equal 1 milliliter. 1 milliliter is small, a pint's bigger. So I can't say there's a lot of big things and a little thing. That doesn't work. Okay, what else? What about B? Well, B is true. Yeah, I can use B, for sure. And I can also use C. But I can't use D. So D is the one that I cannot use. All right, so that is how to make a conversion factor, and then we'll use it in the same way that you would kind of cancel out, like, so going back up here, for example, just to really kind of make sure that I'm being very clear, the same way that I would say 2xy over x cancels out the x. That's what I'm doing here by canceling out the grams. So if you've got a unit on top and a unit on bottom of a fraction at any point in the line, then you can cancel out that unit. So we're going to do a practice. And so what I want you to do is look at this example, the top little paragraph. And I want you to try it first. Set it up. See if you can do anything with it. And then join me again as I go through it. Okay, but don't just watch me do it at first. I actually want you to think about it first. And then a really good way to kind of go through these videos is to, if you're stuck, watch the video only until you get unstuck and then pause it and try to finish it. Be very interactive with these videos, not just like, just don't put them on and watch them. Like this is not a feature film, right? So this is an interactive lecture video. So definitely like let it be interactive. You'll learn a lot better and you'll learn it faster that way. Unless you just kind of watch it, you can't really learn from like osmosis or just watching this. So really sit down and give this some practice. So hopefully you've practiced. These kind of, the slides kind of take you through, but I want to show you kind of how I will solve this problem in my own little way. So your textbook takes you through the steps, and that's just great. But we're going to do a little bit of something. I'm going to show you kind of how to set it up. I think that the setup is more important than the actual work, because getting it out of the word problem is likely the biggest hurdle for a lot of students. And so the doctor's order prescribed a dosage of 0.15 milligrams of Synthroid. So let's just write that down. And I guess I can just write S for Synthroid. I'm not trying to write the whole thing out, like, unless I need to. Tablets contain 75 micrograms, that's mcg. And so that is a conversion factor. I don't know if you saw it, but they're telling me a tablet is equal to 75 micrograms. So I'm going to write that as a conversion, or as an equality. One tablet is equal to 75 micrograms. So now that I have this equality, what can I do with an equality? Man, I can put it on top of each other as a fraction and cancel some units out. It's great. How many tablets? So I'll put this over here. How many tablets for 0.15 milligrams? Okay. So ignoring kind of what they did, let's look at how I would solve this. Now I don't actually need the word problem anymore, and I have everything that I need from the word problem. I want to know how many tablets. I know I'm going to start with this 0.15 milligrams, and I need to convert tablets to micrograms at some point. But I'm missing a conversion. So you ever see those movies where, or TV shows where like somebody's tracking a crime or something, and they like put these, they have this wall of like papers and stuff, and they connect strings to like each paper to show connections between like suspects or whatever. I want you to do that with your units. So let's do a little string connection here. If you're not really sure where to start with where you want to end. If that makes any sense. So let's see where I can go with tablets. Okay, so I know I have to end with tablets. Well, I see a connection to tablet. Tablet connects to tablet, right? That's my string connecting these two things. Tablet also connects to micrograms. What I'm trying to do is connect every piece kind of in a circular thing. I gotta prove that 0.150 milligrams makes tablets, like to prove my case, to solve the crime. I'm missing a connection between micrograms and milligrams. That connection is in your head because you're going to memorize it. Now, I don't know a connection between microgram and milligram, but there's a common enemy here, grams. So let's write our conversions. A milligram is 10 to the negative 3, right? So milli is 10 to the negative 3. Put in our grams and add a 1. Oh, okay, I see. Well, now I have a connection between milligram and gram. So I need to connect gram and microgram now, and I know that one. I know a micro is equal to 10 to the negative 6. And throw in a gram, a 1. Okay, well, gram is equal to micro, and micro connects here. So let's follow this crazy looking thing. If we start with milligram, we can go to gram. Whoops. Gram takes us to gram. Gram takes us to microgram. Microgram takes us to tablet, and tablet is what I want. Look at that. I connected everything. I solved the mystery. Now let's put it together. Now, you can set up your fractions with a multiplication sign in between them. That's fine. I'm going to switch over to my preferred method, which is putting everything on these train tracks. Okay, so these two things are equal ways of kind of putting it together. So every time you cross a track, that's a multiplication. If it's on the top, that's multiplied, bottom is divided essentially. So everything on the bottom of a fraction gets divided. This is how I kind of just like to put it. If you write large, it saves you a lot of space and it just kind of looks clean to me. So, but you can use either way. But please try to use it as some way. Instead of just saying like, well, I know I'm going to divide and multiply, you don't have to think about it. If you write it out in the way I'm about to show you, you don't really have to think about it. Just put the puzzle together and it will show itself. So never start with a conversion factor, because the benefit of being an equality is that it's flexible, right? So think about it, kind of going back here. See how this is flexible? I can put the pints on top, or I can put the pints on the bottom. If I use this first, I lock it in. So whenever you use it, it locks in. Pints on top, milliliters on bottom. And if you're not sure which one you're going to need on the top and the bottom, you don't want to lock it in. So don't use a conversion until you're at the point where you need it. And never start with a conversion if you can help it. So that means I don't want to start with any of these equalities. And I can't start with tablets because that's what I want to know. So I have to start with the milligrams. Just start with the only place that you can start. And it is not going to go over any number. It's just going to be over nothing. You could put a 1 there if you want to kind of hold on to that place, but it is really just nothing. So like if you want to put a 1 there, you can, but I don't like to put anything there because then students start to put units down there. And when you start to put units down there, it means that you're equaling something, and we're not doing that. So just leave it blank. And so what do I need to do next? I need milligrams to cancel. So do you have a conversion with milligrams? We do. Put milligram on the bottom first. Put your unit in the place where you need it to be first. Then let the numbers follow. So looking at my conversion factors, here's my milligram conversion, right? The number that goes with milligram is 1. So that is the number that goes in here. Whatever is equal to this side you just entered goes on the other side of the fraction. Okay, so recapping really quickly. We're starting with the only one that's not a conversion factor, and it's not what we don't know. My milligrams need to cancel out because I don't want to tell you milligrams. I want to tell you how many tablets. I need to cancel it. The way to cancel a unit is to put it on the opposite side of the fraction. If the milligram starts on the top of the fraction, the milligram has to go on the bottom of the next section, or any future section, milligrams can go on the bottom, because as long as it's somewhere on the top and bottom, they're going to cancel out. So milligrams cancel milligrams. And also, these two things on top of each other have to be equal. So I can't say a milligram equals the tablet, because those are not equal. So a milligram is equal to 10 to the negative 3 grams. How do I know that? I just wrote my equality from what I memorized, right? So doing this part out, writing these equalities, is so helpful, because then now you're just kind of putting the puzzle together. You're not really having to think about it too much. So as we go, we can cancel. If I stop here, I have grams. I don't want grams. I want tablets. We got to keep going. So next step, put grams on the bottom. Just automatically, I know that that's the unit that needs to go here. So my grams go on the bottom. What number goes with the grams? 10 to the negative 6, right? What is it equal to? 1 microgram. So notice that I'm kind of talking to myself through this. What goes on the bottom? What needs to be canceled? What's the number that goes with that unit? What is that equal to? That's the kind of process. Talk to yourself. Because usually I'll have y'all talk to each other in class, but we can't do that. So talk to yourself. Or if you're getting in a study group together, like doing a Zoom call with a study group or something, y'all talk to each other. Micrograms need to cancel. What number goes with micrograms? 75. What is 75 micrograms equal to? 1 tablet. Ooh, look, cancel it out. What have I got? I got tablets. That's what I want. I'm done. Now I can press equals. Don't do it in sections. Try to do it go as long as you can before stopping it, because every time you go from your calculator back to your paper, you run the risk of messing up somewhere or writing down a number wrong. So try to keep it all together if you can, all stringed together. I know I'm done when I've canceled everything I don't want and I'm left with the thing I do want. So I'm going to do this math out. And what do I get? I should get out a nice even 2 tablets here. What if we don't get a nice even 2 tablets? For y'all, you're going into healthcare. So you have to decide when you do your math, what you would tell that patient. So if I calculate the dosage to be 2.5 tablets and I know that they can't separate the tablet for some reason, right? Maybe I can tell them 2.5 if they're like, cut this tablet in half. But if I do like 2.8 or something, let's say I get 2.8 as an answer, the patient needs at least this much medicine. If you're not really afraid of like a tiny little bit of overdosing, then you would tell the patient 3 tablets. If you're afraid of overdosing, then you would tell them 2 tablets, right? So you kind of have to make that decision. So when you're doing this on an exam or quiz, when you're doing your workout for me, just, write a little note like, I would tell the patient this many because that's what makes sense. So use a common sense here. When thinking about significant figures, though, how many significant figures would I need? So this has 3 significant figures. These all don't count for significant figures, their definition, and this has 2. So if we're looking at significant figures, so this is realistic. But for sig figs, if you're just kind of thinking about, let me practice that, it would be 2.0, right? Because you have the 75. So, but I would accept either, but you kind of just need to make sure that if you're using a realistic, then just like, right, I would tell the patient 2 tablets. Right, not 2.0. I wouldn't tell the patient 2.0 tablets because they would be like, why are you telling me 0.0? Right, so you can use that. But then if you want to just default to giving me the correct number of sig figs, that's always correct. But if you want to actually think about how you would use dosing is important. If you're in nursing, you will take a nursing math class where you will do this exact math. So thinking about how you really will tell a patient is kind of important. So I will accept that, but just let me know that's what you're doing when you answer the question so that I can give you credit for it. Okay, let's try this one. Let's use a percent. We talked about percent earlier. Let's use it. So pause, then you can come back. So a person who exercises regularly has 16% body fat by mass. If this person weighs 155 pounds, what's the mass in kilograms? Now you can do this because you can do percent math, I'm sure. But I'm going to show you how to use a conversion factor because I think that's more fun. Let's turn this percent into a conversion factor. How do we do that? To turn a percent into a conversion factor, you assume 100 of the whole. So this is by mass. So what unit should I use? Well, pick whatever unit you want. As long as it's the same on both sides, it's fine. Do we want to use pounds or kilograms? Let's use pounds because that's what they give us to start with. So let's just use pounds. So let's say 16% is going to be 16 pounds of what? Because both of these can't be pounds. We got to differentiate between it. So it's 16% body fat. So it's pounds of fat over 100 pounds of person. Sure. And because these two are equal to each other, man, I can flip those around and use them however I want to, right? Because the two things are equal, they are flexible. We can spin them around and use them like we want. So that's how I can write that. The number, kind of think about this as a 100. You see it? 0, 1, 0. There's a 100 there. So use it. If I have 155 pounds and I want to know what is the kilogram of fat here. This is the person. And this is important because you can accidentally find, if you don't do this correctly, and this is also an important question in dosing. If I don't do this correctly, I will figure out how many kilograms 155 pounds of fat is. That's not what the question's asking you. The question's asking you how many kilograms of fat are in a 155 pound person. So we have to be specific. If you don't write pounds of fat and pounds of person here, you might use this conversion wrong. So let's check it out. Do we have everything we need? Can I do my crazy line thing? Well, I have pounds of person, and pounds of person connects to pounds of fat, but I need pounds of fat and kilograms of fat to go together. So what's my conversion between pounds and kilograms? Y'all know that yet? Ooh, you got to know that going to healthcare. 1 kilogram is 2.205 pounds. You can use 2.20. That's okay. So I'm going to call this fat, though, because that's what I need it to be. It could be any of anything. So pound of fat takes me to kilogram of fat. Kilogram of fat takes me to kilogram of fat. There we go. Okay, now I have everything I need. You don't have to do this like crazy line thing. I'm just showing you for your mental, like, what am I doing? How do I know I need a conversion? Because I'm missing one. How do I know I'm missing one? Because I tried to connect the dots and I couldn't do it. So 155 pounds is where I start. Don't start with that conversion. And we're going to actually write everything out. Don't leave anything out. You got to tell me pounds a person. Now, I can't cancel pounds a person with pounds of fat. I got to cancel pounds a person with pounds a person. And it's 100 pounds a person equals 16 pounds of fat. Can you do this algebraically? For the first part, yes, but then you got to do a conversion. So we might as well do the whole thing as a conversion. And I got pounds of fat. It's 2.250. Or sorry, 2.205 equals 1 pound, or sorry, 1 kilogram of fat. And that's what I want, right? I want kilograms of fat. Look at that, beautiful. Gotta make those noises like Bob Ross. He does that when he's painting, makes those little noises. So you can do it when you're mathing. All right, how many pounds of fat we get here? So this is what I get. I get 11.2471655. See if you get that. If you don't get that, holler at me, because you're probably dividing that 100 and then multiplying that 2.25. But I gotta do sig figs. Everywhere we gotta do. Once you learn something in chemistry, you gotta keep on doing it. So how many sig figs do I have? I have 3 sig figs here. I have 2 sig figs in my percent. And the 100 doesn't count because it's part of the definition of percent. And then this does count because it's in between, but don't worry about it. I gave you 4 here, so it should never limit your sig figs. So I need 2 sig figs. Boop, boop, boop. So my answer is 11 pounds of fat. 11 pounds of fat in 155 pounds a person. There we go. So some uses for this you're going to see in your medical studies. LD50 values. LD50 is the toxicity or the lethal dose. LD is for lethal dose in 50% of the population that is tested that die from it. So what is the dosage of table sugar that kills 50% of rats that ingest it? 29,700 milligrams per kilogram of body weight. Ooh, look at that beautiful conversion. Do y'all see it? Look at that. How about you turn caffeine into a conversion factor? Go ahead and pause and turn that caffeine into a conversion factor. Go for it. Did you do it? Did you really do it? Do you have it written on your paper? Okay. So for caffeine, let's turn it to a conversion. You could figure out how much caffeine will kill you. Put your weight in there if you know it in kilograms. Caffeine, 192 milligrams per kilogram of body weight. Every time you see this per, that means conversion. Set it equal, so per kilogram. We're gonna kick this off and we're gonna say equal to 1 kilogram. So what is it gonna look like? 192 milligrams of caffeine is equal to 1 kilogram of body weight. This is for rats. That's how you take anything with per and turn it into a conversion. Miles per hour, doesn't matter. Anything with a little slash, per, conversion factor. Write it as inequality, and then we can flip it upside down, do whatever we want with it. It becomes very fluid. So one of these conversions we need to look at is density. Look at all those conversion factors. Do you see them? Every time you have this little dash, that's a conversion factor. Density is also an algebraic expression, mass over volume. So you need to know how to use it both ways. But I recommend you use it as a conversion factor as often as you can because it's easier than having to train your brain to do 2 different ways of math. So density is a property of how much stuff and how much space. So less dense stuff floats in more dense stuff. Water liquid is 1 gram per milliliter. That is a density you should definitely know. Pretty sure it's on your periodic tables. Anything less than that is going to float, like the ice and the cork. Anything more than that is going to sink to the bottom, like the aluminum and the lead. Okay, so you can tell how dense something is by putting it in water and kind of judging if it's floating or sinking. It's either more than 1 or less than 1. So with this question, we are going to have to think about kind of a way to think about density is if I have a material or a metal and I put it in the water, so I put this lead or this stuff into water, it's going to displace the water. You ever get into a bathtub and the water level goes up? Because you take up volume. You have density, right? So let's say my water level was here. And then I put all these metals and my water level rose. So the volume of the metals I put in is how much the water level rose, essentially. So what I'm doing here is I have this graduated cylinder. It's got some water in it. And so this is my 25 milliliters here. And then I'm going to take a sample and I'm going to put it into my water. And then the sample's inside of it, and now it is 33 milliliters. So what is the volume of the metal? Well, it's the difference between the two water measurements. This is called water displacement. We're just placing the water and to find the volume of this metal, because in order to find the density, I have to have the mass and the volume. Mass is easy, you just put it on the balance, weigh it out. Okay, so now that you know that, pause this and try it. All right, done? Did you pause it? Did you try it? Is it written down? Okay, y'all are gonna get so mad at me asking you those questions all the time, but you really need to practice on your own. Struggle with it. Struggle with it, because then if you struggle with it, you will do a better job of learning it, or the learning is in the struggle. Okay, so let's see, my mass is given to me. My volume is going to be 33 minus 25. Here's a perfect example of, we need to do multiple sig fig rules. Y'all see this? So think about sig figs. 33 minus 25, look at those point zeros. Can't leave them off. They're significant. The person that's measuring this is telling me, hey, it's 33 and I think it's right on that line. So I'm gonna say 33.0. So we can't say we're just gonna not include what you wrote here. So we get 8.0. Don't cut that 0 off, because look, it's to the left of the line. If it's on the left of the line, it gets counted. So how many sig figs in this this volume? There are 2 sig figs in the volume. But if you just look at this, right? 3, 3, 3 looks like 3 sig figs, but it's not. It's going to be 2. You have to. That's what I was saying when you're doing mixed stuff. We have to do it out step by step. So my density is equal to mass over volume, which is 48 grams over 8 milliliters. My units are not going to cancel here. The unit of density is whatever mass over whatever volume you get. And we get 6. But I need 2 sig figs. So I'm going to do 6.0 gram per milliliter is my answer here. So correct anything you need to correct in your notes. Let's do another one. So here I'm going to give you a density. We're going to use it. You know how I want to use it. Use it that way. Try it. Try it that way. If you want to do algebra, go for it. If you want to try it my way, try it my way. Do you see how to do it conversion style? Check this out. Look at it. Ooh, that's so beautiful. 1.32 grams equals how many milliliters? If I say gram per milliliter, how many milliliters am I talking about? 1. Yeah. There's my conversion factor. Isn't she gorgeous? So I want to know, what is the volume? So 14.7 grams. What is the volume in milliliters? And I have this beautiful conversion that goes from grams to milliliters. I have everything. I don't need anything else. I can connect all those things. Can you do this algebra style? Sure. Let me show you the algebra, and then I'll show you the conversion. So the algebra is 1.32 gram per mil is equal to 14.7 grams over x. Solve for x. A lot of people have problems solving for x in the bottom. How do I solve for x in the bottom? You can't. You have to move the x to the top. And there's a short trick of switching out, your density and your volume, but don't worry about that. Just do it out this way, because if you forget what you're doing, you're not comfortable with the algebra. First of all, I would say if you're not comfortable with the algebra, just do it dimensional, just do the conversion. Okay, so your x is going to be 14.7 over 1.32. I'm going to leave it there so you can see how my answer is exactly the same. I'm going to start with my 14.7 grams. I need my grams to go on the bottom. What number goes to grams? 1.32, right? Let's take it down there. What's it equal to? 1 milliliter. Check this out. Bam, bam. Done. Isn't it equal to 14.7 over 1.32? This probably took you way less time than it did to do this. Now, maybe you're really good at algebra and you want to stick to that. It's fine. But what if I wanted you to turn this to liters? Okay, you get your answer here. It's going to be in milliliters. Are you going to remember that? Because I got rid of my units here to do this algebra because I just naturally didn't want to do the units here because it's harder to kind of see the algebra when you do that. So make sure that you are kind of doing this in a way that is going to help you consistently solve these problems. So we should get 11.13636. What my sig fig situation? I need 3, right? Because I didn't do any addition or subtraction. My unit is milliliters because I canceled out the other units. Yeah. Here's your last problem. You're almost done with this lecture. Good job. All right. This one's pretty complicated. So definitely try it, but come back because if you get a little stuck, it's all right. This one's challenging. So this is the conversion, but my answer is also a conversion. So I can't start with not a conversion. I only have a conversion. So I got to start with the conversion. So let's just write this out. 1.92 gram over 1 centimeter cubed. And how do I deal with cube stuff? Okay, so hold on. Let me kind of think about this for a second. I want grams to turn into pounds, and I want centimeters cubed to turn into kilometers cubed. Just kind of pulling this out really quick. So I need some conversions to help me with that. Now I know that 454 grams is equal to a pound. I think that's on the back of your periodic tables. But I don't really know centimeters to kilometers. And I do know to meters though. If you're dealing with a cubed unit, forget about the cube for a second. Let's write the conversion factors without cube. So forget the cube. Let's just write them. So I know centi is 10 to the negative 2. Throw in my meters, stick a 1. And I know kilo is 10 to the 3. Throw in my meters, stick a 1. Now let's make it cubed. The secret to making it cubed is to just cube it. But you have to cube everything. So that means we have to cube everything. And I even cubed the 1. I have a colleague who's got like 17 math PhDs. He's like a genius, whatever. He laughs at me because he's like, you have to cube the 1. You know what? I get it right. I cube the 1 because I forget to cube the other numbers if I don't cube the 1. Because a lot of people will just cube the centimeters and cube the meters and not for the most important thing to cube is this number right here. So if it helps you to cube everything, just cube everything. And I don't even do this where your textbook just puts a parentheses around the whole thing because people forget to cube the number. I do everything. The 1, every unit, and every number gets a cube. And then if you know your exponent math, you can kind of do exponent math here instead of having it like that, or you can just leave it and put it in the calculator like that. It's fine. I'm going to do a little exponent math just to clean it up a little bit because I think it's kind of ugly the way it is. Okay, now what do we want to take care of first? Grams or cubic centimeter? Either one. A lot of students want to take care of the top first. Let's do that. Now grams got to go on the bottom. What number goes with grams? 454. Can you go to kilograms and then use kilogram to pound? Sure. Just take extra steps. It's all right. That's the beauty of this, is there are multiple routes to get there. So grams are equal to 1 pound. Okay, my grams are going to cancel. What am I left with? Pounds over centimeters. Now wait, I want pounds. So I like to circle this, put a little check mark. Don't mess with it. It's good. That's what I want. But I'm not done because I don't have cubic kilometers on the bottom. So how do I cancel centimeters on the bottom? How could I cancel something on the bottom? Put it on top. It just has to be opposite. So what do I have here? 1 cube centimeter cube. Y'all don't laugh at my 1 cube. Over 10 to the negative 6 meters cubed. So we're just going to multiply those together. Yeah. Now my centimeters cube cancel. Well, I'm closer now to kilometers. I got meters cubed. So let's keep going. I know that 1 cube. Whoops. I know that 10 to the 9 meters cubed is 1 cubed kilometer cubed. Cancel those meter cubed. You got kilometers cubed. Isn't that what I want? Yes. So I'm done. Okay. So do this out. So this is what we get. Pounds per cubic kilometer. And we need to do our sig figs. Looks like I got 3. It was my lowest. So I get 4.23 pounds per cubic kilometer. That's my answer here. Yep. Great job. Finished your first chapter.